Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 22nd video in the Introductory Programming in Java full course and the 5th video of Lesson 4, Looping Structures in Java. So far we've covered while loops, do-while loops, looping patterns, input validation loops, and nested loops. In this video we're going to talk about some bad loop design habits and how to fix code with these mistakes. Let's get right into it. Right here I have a program from the last video on nested loops with one small change. At the top we have a quote from Martin Luther King Jr. stored in the variable text, and the program loops through printing one word to a line. In the old version of the program, all of the words were delimited by spaces, and I had removed the punctuation. I challenged you at the end of the video to solve the same problem, but with punctuation. What I've done here is added the punctuation back in, and I've removed the space at the end of the quote, but I haven't changed the code. Let's run the program and see what it does with this new version of the quote. Okay, you can see the program crashes at the end with a string index out of bounds exception, so that's not good. But if I scroll back through the output, you can see that it's including the punctuation as part of the words, and we don't want that. So I'm going to solve this with a bad looping habit, and then I'll show you how to solve it without the bad looping habit. Before you solve any problem, you need to understand what is causing the problem. Let's begin with the punctuation as part of the words. Our inner loop is responsible for reading the words, and that loop starts with while text.char at I is not equal to space. And then, if that's true, so if the current character is not a space, we're printing it and incrementing I. But what if that character is punctuation? Punctuation isn't a space. Programmers will sometimes solve the problem in an in-the-moment sort of way. Here I am on line 23, printing a comma, and I shouldn't be. So a bad solution to this problem, but one that will work to prevent us from including commas as part of our words, would be to write, before the print statement, if text.char at I equals comma, break, semicolon. Now, what does that do? The break statement breaks us out of the inner loop. So if the character we're looking at is a comma, we won't execute the rest of the loop. We won't go back to the loop header. We'll just exit the loop. Let's run the program with this new code. Okay, it still crashes. We do have these weird spaces in the output, but none of the words contain commas. Some people might decide they've solved the comma problem, at least. Now, why is the break bad? Why is this a bad habit? Well, first of all, the program isn't correct. There are those blank spaces in the output. But even if it did give the correct output, putting a break in a loop is a bad habit because it artificially breaks out of the loop. A loop works a specific way. We execute the test, and if it's true, we go in and execute the entire loop body, and at the end, we go back to the test. This loop doesn't do that. Let's see what it does quickly in the debugger. I'll put a breakpoint on the break statement so that we'll see exactly what this break is doing. And I'll click the bug and switch to the debug perspective. Okay, we've stopped on the break. And you can see in the console we have printed, I have the audacity to believe that peoples everywhere can have 3 meals a day for their bodies. And in the quote, this is where we have the first comma. So that's why we're on the break. The test on line 23, text.char at I equals comma, was true. The variable I, our index into the string, is holding the value 98, which is the index of the comma after bodies. I'll step over. Look where we went. We went to system out print line, the first line of code after our inner loop. So we never executed the rest of the inner loop, and we never went back to the test. We broke out of the loop. I'll step over, and I increments to 99. So now text.char at I will be the space after the comma. And that's not right for this point in the loop. This increment is supposed to move the index past a space and to the first letter of the next word. So when I step over, we go to the test for the outer loop, and we're not at the end of the string, so we'll go into the test for the inner loop. But this test will be false because the outer loop didn't move us to the first letter of a word. So when I step over, we jump over the inner loop, and now we're at the print line after the inner loop, the print line that's supposed to flush the buffer to the console to print a word. That is what's causing the blank lines in the output. And then I increments now to the first character of the next word, and the program continues. Okay, so maybe that can be fixed with another break. Of course, you've probably gotten into trouble like this without using breaks. If you write your loop entry condition incorrectly, or if you get the order of statements wrong within your loop, or if you don't have the correct housekeeping code in your outer loop, you can get into trouble like this. The problem with the break isn't that it causes you to write a bug in your loop. I just wanted you to see how it functions. The problem is readability. Line 22 in this program is a lie. As I just said, a loop works a specific way, and part of that is that we always go up to the loop entry condition after the loop body executes. We expect every single line in the loop body to execute. A programmer reading this code will not expect there to be a break in the middle of the loop. They will believe that the loop executes according to the logic of the loop entry condition on line 22. So this makes the code less readable, and it can make it very difficult to debug. The loop entry condition is like a promise or a contract, and the break statement is literally breaking that contract. I know it might not look too bad here because it's a very tiny loop. Remember that most programs are thousands, hundreds of thousands, or millions of lines of code, and there are loops that span pages of code. So a break buried in a loop like that could be very hard to find, and a programmer might not go looking for it because they believe the contract on the first line of the loop entry condition. Now, here's the good news. I wrote a condition on line 23, if text.char@I equals comma. So I can express in logic, using the program state, that I know when there's a special case here. There are two ways I can handle this. One is I can elevate that logic to the condition at the top of the loop. The other is I can handle the situation inside the loop with an if statement. Let's look at the if statement way to handle this here, and in our next bad habit example, we'll look at elevating the logic to the condition at the top of the loop. So what do I really want to do if the character is a comma? Well, I don't want to print it. So suppose I write if text.char@I is not equal to comma, system out print text.char@I. Let's change this code, remove the break, and only print if we're not looking at a comma. Now, what's going to happen with the spaces then? Well, I'll still have my I++, so that should increment the index into the string to the space, and then we'll exit the inner loop, go to the outer loop, and that will flush the buffer to print my word, and then increment I past the space to the first character of the next word. Note that I am assuming there will be a space after a comma, as is standard. Now, if I run this, the words print correctly. No commas, no weird blank lines, but we still get the crash. In fact, notice that the period is part of our last word, spirits. Suppose we write if text.char@I is not equal to comma, and text.char@I is not equal to period in our inner loop. I'll run it. And that removed the period from spirits, but we still get the index out of bounds exception. So what's happening that last time through the loop? In the inner loop, index is 191, the index of the period. We don't add it to our word. We increment I to 192 and go up to the test on line 22. And, 192 is out of bounds. In fact, if we look at the error, go down to the last line number, that's the one in our code that caused the error, and it's line 22, the test for our inner loop. Let's change the test for the inner loop. We probably should have written the test this way to begin with. Check that we're not out of bounds before we try to look at the character at index I. And here's where short circuiting will help us out. I'll write while I less than text.length and text.char at I is not equal to space. Now, if that first test is false, because this is an and, short circuiting ensures that we'll never evaluate that second expression. So if I is out of bounds, we won't try to evaluate text.char at I. Let's run it. And it works, and no crashes, and I have more robust, readable code than I had before. All right. This second bad habit is the while true loop. Occasionally on the internet, you'll see a program with while true as the loop header, meaning the loop entry condition is true. Remember that the loop entry condition is a Boolean expression, and the simplest Boolean expression is a Boolean literal, true or false. So this is syntactically valid. The loop entry condition is the simplest Boolean expression. Remember also that we enter the loop body when the entry condition evaluates to true. So we will enter a loop that has the loop entry condition true. And finally, remember that we always return to the top of the loop to evaluate the expression again. So when execution returns to the top of the loop, we'll enter the loop again and again and again. This is an infinite loop. You've maybe written an infinite loop by now, so you know they're bad. They hang up your program and prevent execution from moving beyond the loop. So in order to end the loop, folks who write while true put some sort of abortive statement inside the loop. A break statement, for example, like we just did. So again, the loop entry condition is a lie. It's a bad contract. I suppose the only advantage to a while true loop is that you know when you see the loop header that it's probably a lie, that there's probably one and possibly many abortive statements buried somewhere in the loop. That doesn't make it better though. A programmer should be able to read at the loop entry condition exactly when your loop is entered. They shouldn't have to dig through every single line to construct that logic themselves. Finally, I'll say that there might be a few cases where a while true loop is more efficient, but in many of those cases, compiler and interpreter optimizations will take care of that efficiency for you. In other words, you write the inefficient readable code, and when it's interpreted to bytecode or compiled to machine code, the bytecode or machine code will be written by the compiler or interpreter with that optimized code. You don't need to write it. So you should write readable code. If you write a while true loop and argue that it's more efficient, you had better be able to explain what compiler optimizations are not in place that lead you to believe so. Otherwise, don't do it. Let's look at an example. Here's our same program with a single while true loop. And if I run it, it works, at least for this text. Now, let's take a look. We have while true. So that means an infinite loop. And then inside the loop, we immediately check if I is going to be out of bounds. And if it is, we break. Remember, that means we jump out of the entire loop. None of the rest of the code in this loop will execute. We then check if the character at I is a period. And if it is, we break. So I have two exit points in this loop. One, which is our original loop entry condition from the outer loop, and another ensuring we stop at a period. Then we are basically executing our inner loop from before, printing the character at I and incrementing I. And then we test for I equal to comma, first checking that we're not out of bounds since we've incremented I, and we increment if so, and then we check if the current character is a space. Now this would have gotten us out of our inner loop before, and if it is, we do the housekeeping from the end of the outer loop before, a print line, and then incrementing I. Okay, so let's talk about how to rewrite this. First, it's not easy to read because there are two different places that we break out of it. These fortunately are at the top, but in many while true loops they're embedded deeper in the loop, making them harder to find. Having more than one break also makes it less easy to figure out exactly when the loop is executing, especially if there's code and logic between them. So the good news, again, is that we know when we want out of this loop because it is written in logic on lines 21 and 24. If text.length is less than I, and if text.char at I is equal to a period. The only difficulty is that these are written as when we want to exit the loop, not when we want to enter it. So in this example, we can complement these and elevate them to the loop entry condition. We'll check the out of bounds condition first, while text.length is greater than or equal to I. Remember, greater than or equal is the complement of less than. and text.char@I is not equal to period. The short circuiting of the and will ensure we don't try to index in beyond the bounds of the string. And I can remove the break statements. And that's it. If I run it, it works. I personally think the nested loop is easier to read, but this loop works for the text example we have here, and it wasn't that hard to turn it from a difficult to read while true to a loop that tells us exactly when we're going to be entering it, and whose full body always executes. This is an honest loop. So between these two strategies, including conditional statements in your loop, and taking your break conditions and elevating them to the loop entry condition, you should be able to structure a loop that doesn't break the contract set in its header, a loop that's much more readable to experienced programmers who know how loops work. It will also require you to think carefully about when your loop is entered and express it in terms of the program's state, which will contribute to writing more robust, correct code. If a programmer can't explain clearly in logic when their loop is entered, do we trust their code? I don't. As usual, I have included some auto-graded exercises in the description of this video, so you can practice with the video code, and the code has been uploaded to my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.